Welcome to The Explainer. Today we are diving into FastAPI. It's the Python framework that isn't just getting a little bit of attention, it is seriously challenging the old guard and completely changing how developers are building modern APIs. So here's what we're going to cover. We'll look at its absolutely incredible rise, we'll unpack what makes it so darn fast, see who's using it in the real world, dig into the critical security trade-offs, and then look ahead to see why it's just so perfectly built for the future of Python itself. All right, let's jump right in by looking at the data, because you really can't understand the FastAPI story without seeing the numbers behind its growth. It's pretty wild. Okay, so if you look at GitHub, which is a pretty great measure of developer interest, FastAPI has actually pulled ahead of Flask, one of Python's most established and loved frameworks. By the end of 2024, it was sitting at nearly 80,000 stars. I mean, that's a huge signal that the community's attention is shifting. But stars are one thing. It's not just about hype, it's about what people are actually using. And in the official Python developer surveys, FastAPI went from literally not even being on the list in 2019 to being used by almost 40% of web developers just 5 years later. I mean, come on, that is an absolutely meteoric rise. So what's the secret sauce here? What is it that makes this framework actually live up to the fast in its name? Well, it really all starts with the foundation it's built on. See, FastAPI is built on something called ASGI, which stands for Asynchronous Server Gateway Interface. Now, unlike the old standard, WSGI, that powered frameworks like Flask for years, ASGI was designed from the ground up for one thing: asynchronous operations. Here's a simple way to think about it. The old WSGI is like a chef who can only handle one order at a time. They take the ticket, cook the dish, serve it, and then only then do they move on to the next one. It's all sequential. But ACSGI? ACSGI is like a modern multitasking chef. They can start boiling water for one order, chop vegetables for a second, and check the oven for a third, all at the same time. Because it never gets stuck waiting, the whole kitchen, or in our case, the server, becomes way, way more efficient. And that approach is the key. It lets a single Python process handle thousands of connections at once. This gives it performance that's not just fast for Python, but actually competitive with languages that are famous for their speed, like Node.js and Go. But listen, performance is only half the picture. The creator of FastAPI really built it for developer happiness. It uses Python's type hints and this brilliant library called Pydantic to automatically validate all your incoming data. You just say what your data should look like, and boom, FastAPI handles all the messy error checking. And on top of that, it just generates interactive API documentation for you, instantly. It's amazing. So with all that speed and this incredible developer experience, let's see where it's actually being put to use. Because some of the biggest names in tech are all over this. And I'm not talking about small side projects here. We're talking about production systems at places like Netflix, Microsoft, Uber, and yep, even OpenAI. These companies depend on it for some really critical stuff. Now, what's really fascinating is where FastAPI seems to be finding its sweet spot. Sure, it's a great general-purpose framework, but its insane performance and ease of use have made it the absolute darling of the AI and machine learning world. Think about it. Data scientists are experts in building models, not necessarily in building web servers. With FastAPI, they can wrap up their complex models into a production-ready API with just a handful of lines of code. It's also become the go-to for building those small, independent microservices that power so much of the modern web. Okay, this all sounds pretty perfect, right? But with a framework that's so focused on going fast and making things easy, you have to ask the big question: what's the deal with security? Can something so flexible and so new really meet the strict security needs of a big company that's handling a lot of sensitive data? Well, the answer, it's a little complicated. Security experts often point out this really important distinction. FastAPI was designed for developer velocity, first and foremost. Its whole philosophy is about getting things done fast, which means security isn't necessarily baked in from the very start. And this brings us to the most crucial point you need to understand. In FastAPI, security is an opt-in feature. The framework gives you all the tools you need, but it basically assumes that you, the developer, know what you're doing. Things like access control, rate limiting, all those critical defenses, they are not turned on by default. You have to add them yourself. So what does this mean? It means if you're going to deploy a FastAPI service to production, you've got to be intentional about it. You need a proper process manager like Tunicorn. You should probably use a web server like Nginx to handle static files. And you have to be really thoughtful about the middleware you add to keep it both secure and fast. Okay, finally, let's look ahead, because the design choices that made FastAPI popular today have also positioned it perfectly for where the entire Python language is going next. I mean, just look at the official roadmap. They are doubling down on performance, especially by integrating with the new Rust-based version of Pydantic, and they're giving developers even more fine-grained control over things like routers and middleware. This all ties into a much bigger trend happening in the Python world right now, which is rewriting performance-critical tools in the language Rust. You're seeing it everywhere, from package managers to data validation libraries. Rust is essentially becoming Python's performance copilot, and FastAPI is built to take full advantage of every single one of those speed gains. And this all leads up to the biggest change coming to Python, maybe ever, getting rid of the global interpreter lock, or the GIL. For decades, this little thing has prevented Python from getting true parallelism on modern CPUs. As Python finally moves towards a GIL-free world, it's the frameworks like FastAPI, the ones built from day one on asynchronous principles, that are ready to unlock a whole new level of performance. And that really brings us to our final thought. The Python language itself is changing. It's getting faster, it's becoming more concurrent, and frameworks like FastAPI, they aren't just following that trend. They're on the front lines, pushing the whole community forward. So the real question is your code ready for what's coming next?